Hello everyone, this is a e-certificate course in Introduction to Renewable Energy Sources. It's a lecture on hydrogen as a fuel. Myself, Shailesh Jaiswal, Assistant Professor, Department of Physics, Shri RLT College of Science, Akola. So these are the contents of my lectures. The first is introduction, then status of hydrogen today, properties of hydrogen, method of production, storage and delivery, uses, why hydrogen and fuel cell, safety implication, challenges, and references. Introduction. Fuel is an material that store energy that can later be extracted to perform mechanical work in controlled manner. Hydrogen fuel is an eco-friendly fuel which use electrochemical cell or combustion in internal engines to power vehicle and electric devices. It is also used in a propulsion of spacecraft. Potentially can be mass produced and commercialized for passenger vehicles and aircraft. Status of hydrogen today. Although hydrogen is the most abundant element in the universe, it does not naturally exist in its elemental form of Earth. Pure hydrogen must be produced from other hydrogen containing compound such as fossil fuels, biomass or water. Currently leading technology for producing hydrogen in the large quantities is steam reforming of methane gas. Engine that burn pure hydrogen produces almost no pollution. So properties of hydrogen, that's atomic number, atomic weight, melting point, boiling point, maximum boiling point, vapor density, specific gravity, flash point, valencies. The hydrogen is a colorless, odorless, combustible gas. Combustive property of hydrogen. The property that contribute to its use as a combustible fuel are its wide range of flammability, low ignition energy, small quenching distance, high auto ignition temperature, high octane number of 130, high flame speed, high diffusivity, very low density, and the hydrogen flame are very pale blue and are almost invisible in daylight due to the absence of soot. It is found that the hydrogen have the higher calorific value. So 141790. Now the production of hydrogen. There are more than 200 viable means to produce hydrogen. Some common methods are steam reforming from coal, electrolysis, thermolysis, photocatalytic water splitting, permittivity hydrogen production, biocatalyzed electrolysis. So is the sustainable part of the hydrogen. So it's a circular chart, gives the supply to demand. The hydrogen which is produced from the many renewable sources and which is used for the transport, buildings and industries, which is shown by the circular chart. The next is the storage and delivery. We can store the hydrogen physically and chemically. Physical storage are the liquefaction, compression, physiosorption, chemical storage, metal hydrate, complex hydrate. Supplier currently transport hydrogen by pipeline or over roadways using tube, trailers or cryogenic liquid hydrogen tanker. For a given volume, hydrogen contains a smaller amount of usable energy than other fuels such as natural gas and gasoline. Because of its low volumetric energy density, hydrogen is a comparatively more costly to transport and store. So now here we see the YouTube video of hydrogen by using this YouTube link. After watching this link of this video, your idea about the hydrogen fuel will become a crystal clear.
Hydrogen. Hydrogen is the first element of the periodic table consisting of one proton. It is the simplest and most abundant element in the universe. Hydrogen does not occur naturally. It is always found in combination with other elements. Water, for example, is a combination of hydrogen and oxygen. Hydrogen is also found in many organic compounds, notably the hydrocarbons that make up fuels such as gasoline, natural gas, methanol, and propane. The tricky part of hydrogen as a fuel source is getting it in its pure form. Hydrogen is primarily produced using two methods: steam reforming and electrolysis, also known as water splitting. Steam reforming is a high-temperature process in which steam reacts with a hydrocarbon fuel to produce hydrogen. Many hydrocarbon fuels can be reformed to produce hydrogen, including natural gas, diesel, renewable liquid fuels, gasified coal, or gasified biomass. Today, about 95% of all hydrogen is produced from steam reforming of natural gas. Electrolysis is a process that splits water into its basic elements, hydrogen and oxygen, using an electric current. The electricity used in the process may come from hydrocarbons or renewables. Hydrogen is an energy carrier, not an energy source. It is an efficient way to store and transport energy. For this reason, hydrogen has a unique and oftentimes little understood role in the global energy system. Some may not know that hydrogen has important applications in the oil and gas industry. Hydrogen is used to process crude oil into refined fuels such as gasoline and diesel, and for removing contaminants such as sulfur from these fuels. Hydrogen is also used in a range of other industries, including chemical production, metal refining, food processing, and electronics manufacturing. Hydrogen can also be used for electricity production through a fuel cell. A fuel cell is an electrochemical cell which produces electricity by converting chemical energy into electrical energy. When hydrogen is combined with oxygen in a fuel cell, it produces heat and electricity with only water vapor as a byproduct. Fuel cells are unique in terms of the variety of their potential applications. They can provide energy for systems as large as a utility power station and as small as a laptop computer. Fuel cells can provide electric motor transportation for vehicles and provide power in stationary and portable power applications. Fuel cells have no emissions at the point of operation. The most significant advantage of hydrogen is that it is an efficient energy carrier. However, the ultimate challenge with hydrogen is getting it in its pure form. While some of its applications appear attractive for environmental reasons, deriving hydrogen requires energy that can result in greenhouse gas emissions and air pollutants that lessen the overall environmental benefits of the technology. In addition, cost and practicality, such as lack of support infrastructure and storage of the highly explosive element, are major concerns. That's hydrogen.
Now here we see the uses of hydrogen as a fuel. The first use is stationary power generation. It's also used in the residential. The hydrogen as a fuel used for transportation with no pollution, and which is also used for the portable power. Why hydrogen and fuel cell? Because of the physical security, because of its reliability, its efficiency, environmental benefits, battery replacement and alternatives, the ability to harvest on a renewable energy like wind, no dependence on foraging oil, zero to near zero level of harmful emissions. Fuel cell vehicle can be up to the 3 minute more efficient than internal combustion engines. And finally, it's a very less noise generated. This so that we need the hydrogen as a future fuel. So it's a safety implication. Colorless and odorless, extremely reactive with oxygen and other oxidizer, low ignition energy, high flame temperature, invisible flame in daylight conditions, negative Joule Thomson coefficient, leaking gas warms and many spontaneously ignite, small molecular size promotes leak and diffusion, very wide flammability limit in air mixture, and it can diffuse into or react with certain metals, embrittling them. The psychrogenetic liquid at 20 Kelvin is even colder than fusion nitrogen, oxygen, or argon. Finally, it's a challenge about the hydrogen as a fuel. Infrastructure. Refueling large scale manufacturing process and support infrastructures such as trained personnel are not yet available for fuel cell system. Hydrogen has to be stored on board vehicle at hydrogen production sites, refueling station and stationary power site which require several precautions. The size and weight of current fuel cell system must be reduced to attain market acceptance, especially with automobiles. Use in fuel cell required catalyst which usually required a component metal. Platinum is extremely rare, expensive and environmentally unsound to produce. So this is the references of my PPT's lecture. Thank you.